Hello and welcome back to part 2 of the Distribution Ninja. Welcome back, students. In our last adventure, the Associates were on a mission to stop the Distribution Ninja from destroying their army of thugs and goons. They sent out hitmen to take out their nemesis. Do you remember that? We had the commutatives, Dr. Identity. The Distribution Ninja fought off thugs and goons, trying to make the city's streets safer. So we have a thug, and obviously you know that guy's a thug because it says so on his shirt. Then you have a goon, and over here we have the Goonies. Great movie. If you haven't seen it, you should definitely go see it. And this thug over here stole a stolen purse. And here we go. We have a stolen baseball. And over here we have the Goonies saying, "Sloth love chunk." That's gotta hurt. Suddenly the commutatives arrive. They attacked with speed, repeatedly smashing in the Distribution Ninja's face. This is quite a battle. Oh my goodness. Then over here, we have these guys. Red and blue guys saying, "Why must we always fight?" And the red guy says, "You said my mom was so old that she knew the Burger King when he was just a prince." And then the blue guy says, "You said I was so fat that when I went to a fat competition, they said, 'Sorry, no professionals.'" The red guy returns, "You said I was so fat that the only part of the alphabet I know is KFC." So I guess that's why Rock'em Sock'em robots are always fighting, because they just tell mama jokes to each other. The commutatives were so fast that the Distribution Ninja had to try something quickly. Oh my goodness, what's going to happen? Suddenly the Distribution Ninja threw out a net to stop the commutatives. They were trapped. What kind of net would that look like in math? Now that the commutatives couldn't use their speed, the Distribution knew exactly what to do. Distribute. It is a Distribution Ninja comic. Figured that would happen. The Distribution Ninja distributed ninja stars to the head of each of the commutatives with a little hua action, which I'll show you here how this works. And this is the distributive property works like this. So if we have a number outside the parentheses like this, it gets distributed like a hua and a hua to everything inside the parentheses, as you will see. That's gotta hurt. Double gotta hurt. The way the Distribution Ninja distributed ninja stars is the way we can simplify expressions. Now, expressions are kind of like parts of an equation, because equations always have the equal to signs in between, kind of balancing two expressions. Expression is just like part of it. When you have a number outside the parentheses, it means we must multiply everything in the parentheses by what's inside the parentheses. So, let's kind of model this situation with, say we had the problem 9 times the quantity of x plus 5. And that's how you would say it with the parentheses. You say the quantity of. So 9 times the quantity of x plus 5, what we would do is, very similarly with the ninja stars, we're going to hua, and distribute. And when we distribute, we're actually multiplying. Now, you may have wondered why, follow ordering operations. Why don't we just add x and 5? Well, x is a variable, 5 is a number. They are not like terms. And since they're not like terms, you can't add them. But when it comes out here to distributing and multiplying, you can multiply things that are not like terms. You just kind of stick them together. So I said this. The 9 is multiplied by both terms, and we're doing a little hua. There we go. We got some good action going on there. Note that even though we can't add or multiply unlike terms, like we said, we can always multiply them. And a common rule in algebra that you really have to start paying attention to is the multiplication and addition rules in general are different. With the commutative stunned, the Distribution Ninja was able to move in and kick some butt. Oh, look at that action. It's like there's 2 of them in the face. So, again, relating this back to our problem, if we had our 9 times the quantity of x plus 5, if we distribute it, it's like there are 2 Distribution Ninjas right here. Oh, let me get that. Well, you can see the pointer. So, this 9 times... Oh, I guess you can't see the pointer. Sorry about that, guys. This 9 times x becomes 9 times x, and then 9 times 5 when you distribute is 9 times 5. The way that there's like two ninjas, there's two 9s going on there. And when we, like I said, 9 and x are not like terms. You can't add them, but we can multiply them by sticking them together, and 9 times 5 is just 45. Now, at this point, can we add up 9x and 45? Just gets sort of like a, I don't know, a 54x somehow? No, you must stop. Okay, this is your answer because these two are not like terms. We know they are not like terms because 9x has a variable, 45 does not. Numbers, variables don't mix. How's it feel, sucker? Probably not good. Distribution Ninja uses technique on other thugs and punks controlled by the associates. Wow, look at all this. Is that guy throwing up over there? Yeah, okay. So, is that puke? Yes, it is. That's gross. Okay, so we're going to relate this problem to, okay, go away. We got that. Sorry, message. We're going to relate this situation here to this problem. And note that thugs and punks are not considered like terms. This guy's got a thug shirt on, this guy's got a punk shirt on. Obviously, they're not the same. But over here, T and P, they are different variables. So no, those are not like terms, and we couldn't just combine them. All right? Now, I'm going to have, you might want to pause the video for a second to open up our glossary, page 15. I would like to add one other property here. We're going to call this the distributive property. And just use this example as kind of a model, right, as we walk through, and you can kind of record how we do this. Puke life. All right, so here we have negative 5 times t plus 2p minus 2t. All right, you ready here? All right, this is what's going to go in our glossary, this example under the distributive property. First thing, we're going to do a little hua, hua, hua. And when you're doing these types of problems, obviously you're allowed to make the noise hua, hua, practice your ninja skills. But it becomes negative 5 times t, negative 5 times 2p, negative 5 times negative 2t. Okay, when you multiply by negative 5 by each term, and if you want to write that down, pause, go ahead at any time in the screen, hit pause. You should get negative 5t, negative 5 times 2p is negative 10p, and then a negative times a negative, and I know that looks like a minus. We need to start getting used to seeing negatives and minuses in the same way. A negative 5 times a negative 2, it's like a negative times a negative gives you the positive 10t. Now the only thing different about this problem compared to the other ones is once you've distributed, you should notice that we do have like terms. Yeah. My mouse is getting stuck here. Okay, any day here, mouse. There we go. Come on. And we're moving. We're stuck. We're moving. There we go. Okay, commutative property says if we wanted to group those like terms, the negative 5t and 10t, we can shift them around. Not that you need to do that. You can kind of do it mentally, but if you do that, it's very clearly negative 5t and 10t give you 5t because the 10t is positive and it's bigger, minus 10p. Combine your like terms, but then of course you must stop. There are no more like terms because negative 10p and 5t are different variables, not like terms. With the thug, were you guys watching? So here's a quick test. How many thug heads were in that pile? Don't be a cheater. Don't go back and rewind the video. Shout out your answer right now. Shout it out. Yeah, okay, you're all wrong. So it was 7. All right, maybe you watch clear. Watch up. Did you see it? Were you watching? Where's the puke? Don't rewind. Don't be a cheater. Did you find it? It's right there. Gross. Okay, what about SpongeBob? Did you see him? You guys aren't very perceptive. You gotta watch. Right there, SpongeBob. What about Kool-Aid Man? Did you see the Kool-Aid Man? I hear you guys from home. You're yelling. You're all wrong. He's right there. Okay, so are you paying attention? How many feet are in the pile? Did you count them? 6. One of them's a barefoot. How many hands are in the pile? Huh? There are 9 if you include SpongeBob and Kool-Aid Man's hands. Okay, with the thugs gone, the distribution ninja, no, still not. What about the butt? Oh, that is weird. Why is there a butt in this? There it is. That's definitely a butt kicking if there's a butt sticking out there. But, so can we get back with the comic? Now the Distribution Ninja can save this old lady from the thugs and walk her back to her house safely. Aw. So there's Distribution Ninja and... What? To be continued? What's going to happen? You'll have to see later on the next adventures of the Distribution Ninja. Alright, before we leave here, I have a shout out for you guys. So my 4th period came up with this idea that we need to do shout outs so they feel special. So first of all, shout out to my 4th period for coming up with that idea. And Vivi says hi to Rhiannon. At least that's what it looks like. And her mom. Oh yeah, she has to say hi to her mom. So that's Vivi's shout out. If you would like to get in on this shout out business, maybe you should leave a little note in the shout out jar. And you can get your shout out read on the next video. So before we leave, I also like to let you guys know that you are important, you are cared for, and you are listened to. I will see you guys later.